Okay, what is the question? You have a number which when divided by 16, 17 and 18 leaves remainder 6, 7, 8 respectively, right? And you are asked to find out if n square plus 5n plus 6 divided by 12, what will be the remainder, right? It's slightly difficult question. How will you solve it? So basically, if you look into this, you understand that this is our division question which we have discussed under type 2 category, where the difference between the divisor and the remainder is same. I tell you how. So based on that, you can find the value of n, right? LCM is LCM minus difference. You will find the value of n. Then you need to substitute the value here, and then you need to find any n. You need to find any n value. Substitute that value here, whatever you are getting. Divide by 12, what is the remainder? So in that way, this is your round 2 question. Okay, before that, how will you write this number? That number can be when divided by 16 leaves the remainder, when divided by 16 leaves the remainder 6, right? So divide by 16 leaves the remainder 6, which when divided by 17 leaves the remainder 7, which when divided by 18 leaves the remainder 8. Okay, so if you see here, the difference is common, 10. Here it is 10, here it is 10. So the difference between the divisor and the remainder is same. So this is my type 2 that we have discussed, where you get a constant difference, right? So what is your answer? LCM of 16, 17 and 18 minus the difference, which is 10. This is the answer if the question is about what is the first possible value of n. But what is asked is, that is not enough. You need to find the value of n. Then you need to find n square plus 5n plus 6, then you need to divide it by 12, and then you need to see the remainder, right? So this itself is a cat level question. So now it is slightly more difficult, right? Now how will you approach? Let me go in this way. See, basically what you need to find is LCM of 16, 17 and 18 minus 10, right? This is what your n. So there is no confusion, right? This is your n. Now if you observe this LCM 16, 17 and 18, this LCM is actually divisible by 12, right? Why? Because you have a 4 here and you have a 3 here. So this LCM is actually, this one is divisible by 12, right? So if this is divisible by 12, and what is your n? N is LCM minus 10. So if you divide your n with 12, you get a remainder minus 10. Remainder minus 10 means what? It is actually 2, right? Because there is no possibility of getting minus remainder. There is nothing but 12 minus 10, right? That is nothing but 2. So if you divide the number, if you divide n with 12, what you will get? You will get 2 as the remainder. So what I did is nothing but I tried to find out the number, right? Number is nothing but LCM of 16, 17 and 18 minus 10, right? So I know that this is divisible by 12. So if I divide my number with 12, what will be the remainder? 2 is the remainder, right? So my n value can be 2. The minimum value that n can take off is actually 2. Now what you need to find out is actually n square plus 5n plus 6 divided by 12. What is the remainder, right? So basically you got the value of n, right? From the minimum value of n, that is 2. Now n can take off different values, right? Now, everything else will increase in steps of 12 then, right? Now if you can substitute that 2 here, you will get the answer. Or what you need to do, you can split this in terms of n plus 3 into n plus 2, right? So there is nothing but if you substitute the value of n is equal to 2, which we got now. If you substitute, you'll get 5 into 4, which is equal to 20. And 20 you need to divide with this 12, right? So you get the remainder as 8. And answer for this question is 8. Now what if you substitute 14, then also you'll get the answer, right? So this will be 17, right? And this will be 16. See, n square plus 5n plus 6, right? Which we can split as n plus 3 into n plus 2. Now you can either substitute n is equal to 2, or n is equal to 14, or n is equal to 26, or n is equal to 38, etc. Now what is this? We actually got the value of n, right? We have seen n is equal to LCM of 16, 17, 18 minus 10. You find the LCM and minus 10. What is the minimum value of n which is possible? That we have seen as 2, right? Because we know this is divisible by 12. So minus 10 means the remainder will be 2. Or if this total you divide by 12 means remainder will be minus 10. And that means remainder is 2. So n is 2. And you substitute here, you get 5 into 4, which is equal to 20 divided by 12, you get 8. Or if you substitute this value as n, it becomes 17 into n plus 16, right, divided by 12. Now this is nothing but again here you can individually divide, right? So 17 by 12 you get 5, 16 by 12 you get 4, that is nothing but 20. Again you need to divide by 12, you get 8. So I hope you understood. See, it's a complex question. Actually they are asking you to find the LCM of 16, 17 and 18 minus 10. You get a number, right? You can manually find it also. 16 means 2 raised to 4 into 17 means no other prime factors. 18 means 3 square into 2, so I'll take 3 square. This is LCM minus 10. You get this n value, substitute and divide by 12 and you can get the answer. That is one way. Otherwise what we did is LCM of 16, 17 and 18. We know this is divisible by 12 because there is a 4 here, there is a 3 here. So if I divide the n is what I need to find out first, right? If I divide n by 12, I get remainder 2. And that I can take as my first n value. Then everything will, the next possible value, I need to add this 12, right? 14, 6, 26, etc. it will go. So after getting n is equal to 2, you just put it in that equation, n square plus 5n plus 6. There is nothing but 4 plus 10 plus 6. That is nothing but 20, which is greater than 12. You need to divide by 12 again, you get 8. Or easy method, you can split n plus 3 into n plus 2, right? There is nothing but 5 into 4, which is also 20, divided by 12, you get 8. Whatever way you want, you can do it. See, the question is difficult just because they are not asking you to find the minimum value of n. They are not asking you to find any value of n. They are asking you to find value of n. After that, you need to substitute in an equation and you need to find the remainder when divided by a different number, 12. So how we did is, we understood that it is type 2 question, LCM of 16, 17, 18 minus remainder. And this is divisible by 12 when, if you can add 10 more. That means with this number, if you can add 10 more, you can divide this number completely by 12. Then what is the remainder? Minus 10 now. That means you need to add 10 more to be divisible by 12. So what is the remainder? Minus 10 or plus 2. Because you need to add 10 more. Or your number is actually 10 less than a multiple of 12. So what does this mean? Minus 10, that means plus 2, right? Then you got n value, you can substitute and you can get the answer faster. Now in this question, 7 raised to 84 divided by 342, you need to see what is the remainder, right? Simple question. We have discussed the same question when we discussed the example of number ending in 7, right? If you remember, we have discussed the same question in fact. So how will you do this? See, this is similar to 2 raised to n number case that we have discussed, right? You need to factorize the numerator. Here you need to factorize the numerator in such a way that when you divide with the denominator, leaves a plus 1 or a minus 1 as the remainder, right? Now if you look into 342, you know 7 cube is 343, right? So we'll write it as 7 cube raised to 28 divided by 342. What does this mean? Your 7 cube by 342, if you do it once, you get 1 as a remainder. Why? 7 cube is 343, 343 by 342, 1 is the remainder. So how many times how many times you can factorize like that? 7 cube will be there for 28 times, right? So 1 raised to 28 is 1. Answer for this question is option B, right? Right? Okay, so how will you solve this question? This is nothing but 7 raised to 3 raised to 4n plus 1, right? So what you need to do here, you just put n is equal to 1. So this becomes 7 raised to 81 plus 1. Now it's easy, right? You know the method of finding last digit of number ending in 7, right? Because last digit of number ending in 7 we can solve by using the concept of power cycle of 7, right? So what is power cycle of 7? 4. Oh, the frequency is 4, right? So what we'll do, we'll take out the power 81, divide by 4, see what is the remainder, right? What is the remainder? Remainder is 1. So you'll write 7 raised to 81 as 7 raised to 1. And what is 7 raised to 1? There is nothing but 7. 7 plus 1 is equal to 8. What is the last digit? 8. Why? Because if you expand this number 7 raised to 3 raised to 4n, if you put n is equal to 1, last digit is going to end in 7, right? Now if you add 1 to that, it will be 8. Whatever be the value of n. Now will you solve it? What they are asking us, 8330 raised to 1957 plus 8370 raised to 1982. What is the last non-zero digit, right? So how will you find the last non-zero digit? Now tell me whether this number is important for you. No, this is not important, because if you see the power, you can understand that this number will have more number of zeros. Okay, so see, it will be like this. If you expand this number, then last non-zero digits will be like x, y, z. Then there will be zeros, right? There will be zeros. Now you know this is, the power is more, so definitely there will be more zeros, right? So if you expand this number, definitely there will be more zeros, 0, 0, 0, 0, etc. will go. So if you see the last non-zero digit here, it will be z. Now it will go like this, right? And that depends on the first one. That depends on this only. So basically, if you need to find the last non-zero digit, when you add these two numbers, effectively you need to find the last non-zero digit of this, because this is having more zeros and that is not going to make any impact. So you just need to find what is this digit, right? What is the last non-zero digit of the first number? So how will you find it? There is nothing but 83301957. Last digit is what you need to find out. So we change the question, find the last non-zero digit of this one, right? So there will be many zeros because number is ending in 0, and you know that this much power is there, so definitely there will be zeros, right? So avoid those zeros. So you need to find the last non-zero digit. So if you need to find the last non-zero digit, it will depend on the last non-zero digit only. So now you can change this question to 833 raised to 1957, because this is not important for me. Now number ending in 3. So to find the last digit of any number, now you need to find the last digit of this number, right? Now to find the last digit of a number, only you need last digit. You don't want this previous digits, right? So I'll change the question again to 1957. Now it depends on number ending in 3, find the last digit, right? We know the power cycle of 3 is 4, or the frequency is 4. So we need to divide by using 4 and see the remainder and write in that way, right? So then what you can do, you can simplify this again, right? Because we are going to use the power cycle of 4. Now power cycle of 4 means you need to divide the power by 4, right? So divisibility of 4, it is basically based on the last two digits. So 1957 is not important for you. You just need to know the last two digits remainder, right? So when you divide the last two digits, what is the remainder? It will be same as that of 1957 divide by 4 and last remainder, right? So you can convert this as 3 raised to 57. So ultimately what we converted our bigger question into, like, what was your question? 8330 raised to 1957 plus 8370 raised to 1982. We converted this to this first, then we converted in this way. Now finally we are writing it as 3 raised to 57, last digit. Now then what you will do, 57 divided by 4, see what is the remainder, right? What is the remainder? 1 is the remainder. So what you will do, now you will write it as 3 raised to 1. What is your answer? 3. So I hope you understood. What was the question? 8330 raised to 1957 plus 8370 raised to 1982 was the question, right? Now to find the last non-zero digit of this number, we just need to consider this number only, because this is having more zeros, so that is not going to make any impact, right? And to find the last non-zero digit, we don't want to consider this 0, so it becomes 833 raised to 1957. Now you need to find the last digit of this, right? Number ending in 3, you know how to find the last digit, and for that this 2 is not important, right? So you write it as 1957. Now you can write it as 3 raised to 57 because you need to divide this number by 4, so you are applying the divisibility of 4. Now this, when you apply the divisibility of 4 and write like 3 raised to 57, and when you divide by 4 and see the remainder, you will convert it as 3 raised to 1, and your answer is 3. So this answer for this question is 3. Now in this question, n is given as 1421 into 1423 into 1425 divided by 12. You need to see the remainder, right? So basic remainder theorem is what you need to apply. We have already discussed this question, right? So you will see the individual reminders, right? 1421 divided by 12, you will get remainder as 5. You get remainder 7 in this case. You get remainder 9 in this case. So which is again greater than 12. So you need to divide it with 12 again, right? Because the numbers which you got here, your remainder depends on that number. So if it is greater than that divisor, you need to divide it again and you get remainder as 3. Okay, how will you solve it? What they have given us, 10 raised to x by 13, right? You are getting a remainder 1. If you divide 10 raised to x by 13, you will get a remainder 1. And if x is a set of natural numbers between 100, right? How many different values x can take, right? So how will you find the answer for this? See here, this is nothing but the application of Fermat theorem. So this x must be nothing but Euler's number of 13, right? If you need to get this as 1, x must be the Euler's number of 13. Now 13 is a prime number, so Euler's number of 13 will be 1 less than that of the number. So it is basically going to be 10 raised to 12 divided by 13 will give you 1. Now what is Fermat theorem? You have two numbers a and b, right? Now the Euler's number of b, if you are writing as a power of a, let's take e, your remainder will be always 1. This is what Fermat theorem, right? Now what is the condition? These two are coprimes and here these two are coprimes. So if you have 7 by 9 raised to, if the power of 7 is 6 and divide by 9, what will be the remainder? Remainder will be 1 because 6 is the Euler's number of 9. At the same time 7 and 9 are coprimes. Now what are coprimes? Two consecutive numbers, natural numbers are coprimes. Two consecutive odd numbers are coprimes. Any two prime numbers are also coprimes, right? And not only 7, instead of 7, if it is 5 divided by 9, if the power is 6, instead of 7, if it is 5, still the remainder will be 1 because 5 and 9 are coprimes. And still 6 is a Euler's number of 9, right? So that is what applied here. So if 10 raised to x divided by 13, remainder need to be 1, x has to be 12 as per Fermat theorem, right? So x is 12. So the moment you understood this, then the question is over. You are looking for how many multiples of 12 are there under 100, right? So you get 8, but 8 is not a correct answer. Most of the time, you know, if you look into the answer choices, your first options will be 8 and you'll mark it as the answer, right? Why it is not correct? Because Euler's number is not necessarily the least number which will give you a remainder 1. It can be the factors of Euler's number also which can give you a remainder 1. Sometimes Euler's number itself can be the least number. Sometimes the factors of Euler's number is also possible. So here, since it is 12, okay, so here since the power is 12, that is Euler's number of 13 is 12. It's not necessarily the power 12 will give you 1. You need to check for the factors of 12. What are they? 1, 12, okay, 12 anyway we know. Then 2, 6, then 3, 4. So we basically need to check for this also, right? So if you see 10 raised to 1 by 13, you get the remainder 10. So this is not 1, no problem. What about 10 square by 13? You get remainder 9. Then this is also not a problem. Now if you check 10 cube by 13, you get minus 1 as a remainder, right? So if 10 cube, now it's over, right? Now we don't want to check other numbers. If 10 cube by 13 is minus 1, 10 raised to 6 by 13 will be plus 1 as a remainder. 10 raised to 9 by 13 will be minus 1. 10 raised to 12 by 13 will be again plus 1, right? Alternate minus 1 plus 1. So this is minus, this is minus, this is plus, and this is plus. So effectively, you need to look for how many multiples of 6 are there in a range of 1 to 100. And your answer is 16. Because in this 16, the multiple of 12 is also counted. Okay, you don't want to count it separately, because when you are looking for multiple of 6, the multiple of 12 is also counted, right? So 16 is your answer, not 8. Why? I hope you understood. Why you are marking 8? You understood this is Fermat theorem, right? This is x, and 13 leaves the remainder 1 means it has to be 12. So you know Fermat theorem. So as per that, 10 raised to 12k series, any 12k number will give you remainder 1 when divided by 13. This can be 12, 24, 36, etc., etc., up to 96. So how many such numbers are there in 12k series is what we are actually looking for. How many multiples of 12 are there in 100? So you got 8, right? But what I told you is, Euler's number is not necessarily the least number which will give you the least power which will give you remainder 1. There can be numbers which is factor of 12 will also give you the same. That's what we have seen here. 10 raised to 6 by 13 if you do, you will get a remainder 1. And how the 6 and 3 is related? 6 is nothing but factor of 12. And what is 12? 12 is nothing but the Euler's number of 13. Right? So in that way also you can get the answer. So what is the answer for this question? You need to look for the multiples of 6 in 100, and answer for this question is 16 and not 8. Now one thing which you can keep in mind is, if you see 7 into 11 into 13 will give you 1001. Okay, so 10 cube divided by 7 will give you minus 1. 10 cube divided by 11 will also give you minus 1. 10 cube divided by 13 will also give you minus 1 as a remainder. We can use this to solve different questions. Okay. Okay, what is the answer for this question? 34041 and 32506, right? So basically, if you divide this with a number, you get a remainder. If you divide the second number with the number, right, you get the same remainder, right? So what is the number is what they're asking, right? So this n is same and remainder is same, right? But what is given? What is given is this n is a 3-digit number. This n is a 3-digit number, right? So you have been given two numbers, 34041 and 32506, and divide by a 3-digit number, right? These two are same divisor and gives the same remainder, right? So the moment you see this concept, same remainder, constant remainder, etc., what need to come to your mind? AP, right? So we have discussed the same remainder or constant remainder concept already in constant remainder theorem, right? So basically you need to assume that these two are in an AP, right? With a common difference of, what is the difference you get? 1535, right? So what does this mean? This number, if you divide by 1535, you get a remainder, and if you divide this number with 1535, then also you'll get a remainder. Both remainders will be same. That's what constant remainder, right? And not only this difference, the factors of the difference will also give you the same remainder. So if you see one of the factor, it is 307, and that's what actually asked here. They are asking, so in this question, in this case, this can be one of the value of n, right? But in the question, what they are asking is a 3-digit number, so this cannot qualify for your answer, right? So what is the answer? 307. 307 is a factor of 1535. And 307 is a 3-digit number which satisfy my condition, so I'll pick 307 as my answer. So what we applied? We applied constant remainder theorem that we have already discussed, right? What is that? You take the difference, you divide two numbers with the difference, you'll get the same remainder. And not only with that difference, if you divide with the factors of the difference, then also you'll get the same remainder. That is the idea. Okay. Okay, in this question what you need to do, it is similar to the previous question that we have discussed, right? So here it is x raised to 6 by 9 is giving you remainder 1, right? So x is a natural number. How many different values x can take place in within a range of 1 to 100, right? See, in the previous question, this was given as x, right? Now this was given as x. So again, based on Fermat theorem only. So if you see, 6 is the Euler's number of 9, right? So see, if this is the case, 7 by 9, if this is 6, what will be the remainder? 1 will be the remainder. What is the reason? 6 is the Euler's number of 9 and 7 and 9 are coprime. And not necessarily 7. Any number which can come as coprime with 9 will give you the same remainder, right? So what if it was 5? If it was 5 by 9, 5 raised to 6 by 9 will also give you the remainder 1. Because 5 and 9 are coprime. Not only 5, if you take 4 by 9, 4 raised to 6 by 9 also will give you 1. 3 by 9 will not give you 1 because 3 and 9 are not coprimes. They have common multiples, right? Not only 1, 3 is a common multiple. So basically what I am looking for x values which are coprime with 9. That means I am actually looking for x values which are non-multiples of 3. If it is non-multiple of 3, it will be coprime with 9, right? That is the idea. So I'm looking for numbers like 1, 2, 3, no. 4, 5, 6, no. Why? Because this is a multiple of 3. This is also a multiple of 3, right? So in 100, how many such numbers are there is what I'm looking for, right? So 98, yes. What about 99? 99 is a multiple of 3, no. Okay. Now here it's not from 1 to 100, right? So here it is from actually 100 to 200, right? So what you need to do, you need to see how many multiples of 3's are there, subtract it from 101. Why 101? Because total 101 terms are there including 100 and 200. So 100 minus multiples of 3. Now that you cannot manually count, right? Why? Because see, multiples of 3, 100 by 3 is what you need to do. You know it is either 32 or 33. You know it's either 32 or 33. But don't make any mistake here, right? When you are taking, you should take it perfectly like... see here what you need to do is 101 minus 33, you get answer as 68. Now if you have any confusion in taking 33 from here, you can do it manually because there is a high chance that you will make an error here, right? How will you do manually? What is the from 100, right? From 100 is what I am looking for. So I need to see, first I need to see this total number of terms is 101. I need to see number of multiples of 3. Okay, so let's see how many multiples of 3 are there. 102 is the first multiple of 3, right? What will be the last multiple of 3? So now you know the first term, you know the first term, you know the last term, you know the common difference as 3. You can find the number of terms, number of multiples of 3. There is no need to make any guess or no need to make any mistake. Okay, otherwise you can do this 100 by 3. It's either 32 or 33. Don't make a mistake. If you can pick it directly 33, okay, fine. There is a chance that you may take 32 also, right? See, if your option, how will you pick it? You look for options, right? If 68 and 69 is there in your option, you do it manually. If in your option you can find only 68, you don't want to do this thing. You know it's either 32 or 33. So I need to do 101 minus either 32 or 33. So my answer is going to be either 68 or 69. So if your option contain only 68, you can pick it. If your option is having 68 and 69, you do this. Okay, don't make any mistake. Do this. How will you do it? Last term minus first term. 198 minus 102 divided by 3. That is a common difference plus 1. Last minus first divided by common difference plus 1, right? So 96 divided by 3 plus 1. That is nothing but 32 plus 1, 33. So you got number of multiples of 3 as 33. Then your answer is 101 minus 33, which is nothing but 68. So here in your option there is no 68 and 69. If you have 68 and 69, you need to do this calculation. Otherwise, you know 100 by 3, it's either 32 or 33, right? So what are the possibilities? 101 minus 32 or 33. So it's either 68 or 69. If your option both are there, do it manually. If most probably they will give you only one option.